Hi everyone, I'm Kington and this is Coding is for the Birds. We're working through the advent of code problems from 2021 and this is day 4. All right, pause the video and take a look at the problem if you haven't already. So what we need to do is play some bingo. We're going to be given a list of numbers that will be chosen and we're going to be given a bunch of bingo boards, and then we need to go through the game until somebody wins. In this version of bingo, only a horizontal row or a vertical column can win. Diagonals don't count. And once someone wins, we need to calculate the score for that board, and it's going to be the sum of all the unmarked numbers on the board times the number that was called that caused the win. All right, so first we're going to need to figure out how we're going to store these boards. We could have a two-dimensional array of ints for each board. We also need to keep track of which numbers have been called. I think, let's see, we might be able to use 0. Nope, 0 is a valid number on the board. That makes things a little more annoying. How are we going to do this? We could have Boolean arrays that go along with the number arrays. We could write a little class to keep track of a bingo hand. I guess we'll do that. So let's have a static class card, and it will store our arrays. And we're going to have an int two-dimensional array board or numbers. We'll say numbers and Boolean. Can we do this? Oh, not Boolean int, yeah. Okay, I think that'll work. I don't know we'll have a Boolean array called that is the same size. And so as we go through our input, what we're going to have to do is keep track of the numbers that are going to be called. So this is going to be an int array, numbers to call, and it's going to be, I guess we'll make this a string array for starters. This is going to be in.nextLine.split, where there's a colon. Pretty sure it was commas. I meant a comma. Yeah, comma. Okay, so we split it where there's a comma. That'll give us the numbers we're going to call. Then we need to read the blank line, right? So there was a blank line after that. And then we're going to read 5 numbers and a blank line each time. So while in has next line, we'll say for 5, we'll get a line. Now this line needs to be split where there are spaces. Okay. And then we'll go through nums. And we need to convert that to a number and put it into a card. So each time we're here, we're going to create a card. And then here, we'll say card.numbers. And we're going to do we want to do X, Y? Does it matter? I guess it doesn't matter at all, because rows and columns, it makes no difference how we do this. So convert the number, nums sub j, to a number, put it in our card.numbers array. And then here we have to read the blank line that was at the end of the cards. And I think this is probably going to work. We need a list of cards here. Okay. And let's, I wonder what will happen if I print cards. I bet it won't print anything useful, but let's see what happens. We'll at least find out if this gets an exception or something. Okay, so we did get an exception. I wonder how many cards we got through here. Let's see how many times we get to this line. 0 times. Okay. Oh, that's right. No, that's not the problem. Read a line and we split. Let's just go ahead and debug this a little bit. It's going to be something dumb. Numbers to call is an array of 100 numbers. That seems pretty reasonable. Oh, I meant to, yeah, I meant to eat the blank line after that, and I didn't. Okay, so here we need to just throw away the blank line. No, that's still not the problem. Okay, so we read the numbers, we split, we eat the blank line, create a card, get a line. Line looks good. Nums is 5 strings, that's fine. I'm going to parse these. Okay. So let's set a breakpoint here. Okay, we got another line. We got another line. Okay. What went wrong here? Okay, 1, 2, 3, 4, 5. The third number didn't work. I'm confused. Our 5th line is blown up for some reason. Oh, there are 2 spaces here. That's the problem. So lines.split. Yuck. Lines.split is coming out wrong. Okay, so I think split is a regex. Yeah, it is. So I can say, I think I can say \s star here, and this should, or not star plus. That ought to take care of it probably. Okay, when we do that, now we get 5 strings. Okay, so this is going to be okay now. And then I think if we look at card numbers, we're seeing something reasonable here. Let's get rid of this breakpoint, let it run. Okay, so did it explode there? I think it did eventually. It did eventually throw an exception. Right here, we're just going to say if the string is empty. So if line equals empty string, then we'll break outer. And here just say outer. So I think that'll probably work. Really? Can't really be down here, can I? No, I'm on %. Okay, what's wrong now? My last line is this one, okay. So this string getting parsed is going to be, this one's going to give me an empty string at the beginning. That's really obnoxious. Okay, so this time we'll say line.trim before we split it. And now we should always get, okay, good. Now this time we're getting a no line found here. So actually we can get rid of this in.nextLine and the one before the loop and fold them into each other here. Okay, great. All right, so we've got our cards, I think. The print line didn't really do anything useful, but I'm thinking it's working. So now we'll say for string numster in numbers to call. and num equals %num_stir. Convert that to a number. Now we're going to go through our cards. And then we're going to say, we'll have like a mark method in card. So we'll say mark the card, card.mark num. And I guess this can return true if there's a bingo. So we'll say if, or we can even, we'll just say card.mark num. And we'll say if card.isBingo, then sys out card.score and return. Okay, so now we need a mark, an isBingo, and a score method here. So we're going to say mark is a void mark, and it takes a num, and then we're going to say for row in, no, it's int array. No, since we need the Boolean, I guess we're just going to do this the simple way. I equals 0, I is less than 5, j is less than 5, j plus plus. If numbers y sub j is equal to num, then we're going to mark it off. So we'll say called sub I sub j equals true, and return because the number can't appear twice on the same card. We're going to have a Boolean isBingo, and we're going to say for each, okay, for I0, I is less than 5. So we're looking at a row or a column with I, and then I guess we can do it both at the same time. Boolean row is true, Boolean call is true. And then here we'll say if not called sub I sub j, then we'll make the row false. If not called sub j sub I, then we'll make the call false. I don't really care which is which. All we care about is whether one of these is still true at the end of our loop. And so we'll say if row or column, then return true. We had a bingo. Otherwise, we're going to return false. And then our score is the sum of the uncalled numbers. The score for the card, we'll say it's that, and then we can multiply it by the last called number back out in main. So we just need to add up the uncalled numbers here. So let's grab these loops. And sum if not called I sub j, then we add the number to our sum. And then back up here, if the card's a bingo, get the score, multiply it by the number that we just called. So what happened here? Let's get rid of this print statement. And then apparently we're not getting a bingo somehow. It's printing out all the numbers, never hitting. It's never hitting this. All right, what's wrong? Let's try debugging some of these. Let's see if we ever mark a number off. Looks like we did not. Well, that's interesting. Are we not calling Mark? Was nothing in cards? Oh, I forgot to add. You know what? When we printed cards and it was an empty array, that's because I actually forgot to add the card to the list. Okay, that's what's wrong. Now run it. Okay. Maybe this will be the right answer. All right. So is there anything particularly interesting in this code? This is a nice thing to do. This required a little understanding of split. So when we had two spaces in a row and we're splitting on a space, we're actually going to get two matches with the regex, and we're going to wind up with an extra empty string in our array. So that was screwing this up because I was expecting it to always come out as 5 numbers. And then when we did this split with a leading space, we also got an extra entry in the array. And that's why I needed to add this trim here. So that was a little bit tricky. Other than that, there's really not much to this. One thing that made this easier is realizing I didn't need to care about rows versus columns, because our bingos can be horizontal or vertical and we don't need to know which way they were. And that means that I don't need to think too much about whether I should go IJ or JI. As long as I'm always consistent with numbers and called, then we'll be checking off the right numbers, and we don't really care which way the arrays are going. The is bingo, this was slightly clever, I guess, being able to check a row and a column at the same time. So here, we're starting out assuming the row we're looking at will be a bingo and the column we're looking at. And we're going to be looking at row I and column I at the same time. So when this is 0, we're looking at the first row and the first column. As j goes from 0 to 5, we're going to be checking 0j, and whether that's a row or a column doesn't really matter. I called it row. So if we find a number that has not been called in that row, we set row to false. As we loop through, also checking j 0. And so if this is a row, then that is a column. And we're going to mark column as false if we find an uncalled number there. And so when we get to the end of this, we know if the row or the column is true, then we have found a bingo. So this is a little bit less code than we might have written otherwise. And then there's really nothing to score at all. We go through the grid and add up all the numbers that have not been called. All right, let's have a look at part 2. So for part 2, we want to win last. So we're going to figure out which board wins last, keep that one, and then when it does eventually get a bingo, we're going to calculate the score the same way as before. All right, so this shouldn't be that hard, actually. What we could do here, switch this to go through the cards with an iterator. Now, while iter.has next, no, I should call it iter. This is a pretty common idiom, so we'll say card equals iter.next. And we often write a loop like this when we want to be able to remove elements as we iterate through the list. In Java, if we try to delete from a list while we're iterating through it, using something other than the iterator itself, then we'll get a concurrent modification exception. If we do it this way, we don't have to worry about that. So if the card is a bingo, if cards.size is greater than 1, then we're going to throw away the card that won. So we'll say not card, but iter.remove. That'll throw the card out. If we're down to the last card when we got a bingo, then we're going to print bingo just as we did before and print out the score. So as we go through getting bingos, we'll be throwing cards away. Eventually we'll get down to 1, and we should print the score for that out. 7075. Let's see if that's right. It is. All right, maybe we'll be able to save Christmas after all. All right, well, that was a little easier than the previous problem. We'll keep working through these and hope to save Christmas. Daisy has to hit the road. Thanks for watching. Don't forget to like and subscribe.